So welcome to this latest video 162 Maths, and in this video we're going over the GCSE Maths higher topic of probability and combinations with a focus of what it is you need to revise and going through some exam questions. Now as always I'll include a copy of the question paper that we go through in this video for you to have an attempt at, and all you need to do is just simply click on the link in the description below. So let's get straight into these GCSE Maths higher questions related to probability and combinations, including in product rule for counting. So looking at question 1, it says that a restaurant has a deal of some dishes when you order 3-course meal, and this deal includes 8 starters, 5 mains and 4 desserts. 3-course meal includes 1 starter, 1 main and 1 dessert. How many different 3-course meal deal combinations are there? So for this, all we need to do is adopt the product rule for counting, and that is by to work out the total number of combinations is just multiply the number of options in each strand. So it's going to be 8 times 5 times 4, which gives me an answer of 160. Then for 1b, it says 3 of the starters have fish in them, 2 of the mains are pasta dishes. Steve picks a 3-course meal combination at random. Work out the probability that the starter has fish in it and the main is a pasta dish. Give your answer as a fraction. Well, for this, we know that he's definitely going to pick a dessert, so the dessert's not really an option. So it's just more of a case of what's the probability of him selecting a fish starter, and that's going to be 3 out of 8, and a main course that contains pasta, which is going to be 2 out of 5, and then he's going to pick a dessert which doesn't really make a difference, so that's going to be 4 over 4. So then multiplying each of those, we get 6 over 40, or we can simplify that fraction as 3 over 20. So any of those two would be fine. Now for 2 marks, it's always really important that you do show some working out, or the second mark could be from simplifying your answer. But I wouldn't personally take that risk. I would just try and show as much working out as possible. Moving on to question 2, it says a pet shop has 6 rabbits, 8 hamsters, 5 lizards and 3 parrots. The store wants to pick one of each type of animal to be on the new poster. In how many ways can the pet shop pick for the 4 animals? So again, we're going for a product rule of counting. So we multiply each of the number of options in each particular strand. So that's going to be 6 multiplied by 8 multiplied by 5 multiplied by 3, giving me an answer of 720. Then for 2b, it says the pet shop sells 2 hamsters and a lizard. Before picking the animals, in how many ways can the pet shop now choose the 4 animals? Well, if 2 hamsters have gone, so that means there's going to be 6 hamsters left. Number of rabbits have not been sold, and lizards one has been sold, so that's going to be 4 lizards, and the parrots number is still the same. So how many combinations are there? Well, it's going to be 6 times 4 times 3, which gives me an answer of 432. Moving on to question 3, it says Jill and Michael each pick 3 single-digit numbers from 1 to 9. Jill only uses prime numbers and Michael only uses multiples of 3. Jill can make X more combinations than Michael. Assume that all digits can be repeated. Work out the value of X. So for this, what we need to do is first of all work out the number of options, the numbers that Jill can pick. Well, she's only using prime numbers between 1 and 9. So the prime numbers are 2, 3, 5 and 7, and for Michael he's only picking multiples of 3 between 1 and 9, so that's going to be 3, 6 and 9. So then calculating the total number of combinations, well, that's going to be 4 times 4 times 4, because Jill's got 4 possible numbers to choose from, and it's a 3-digit number that they're picking. For Michael, that's going to be 3 times 3 times 3. So this total for Jill is going to be 64. The total for Michael is going to be 27. So then the difference, which is X, so X equals 64 minus 27, which gives me an answer of 37. It then says, in fact, digits cannot be repeated. What does this tell you about the actual value of X? Well, it's actually therefore going to be smaller, because therefore Jill is going to be, well, in terms of her options, is going to be 4 times 3 times 2, which is 24, and Michael is going to be 3 times 2 times 1, which is 6. So as you can see, the difference is 18, which is smaller than 37, so it's going to be smaller. Moving on to question 4, it says Jordan owns 14 movies, of which 2/7 are science fiction, 5 TV box sets, none of which are science fiction, and 8 console games, of which 95% are science fiction. Jordan picks 1 movie, 1 TV box set, and 1 console game. How many possible combinations have no science fiction in them? So let's first of all do a non-sci-fi count. So in terms of the movies, if I can spell it, which clearly I cannot. So in terms of the movies, now 2/7 of 14 is going to be 4. So 4 films are science fiction. So movies that aren't science fiction are going to be 14, take away 4, which is 10. Then looking at the box sets, well, it says that none of which are box sets, so that's going to be science fiction, so that's going to be 5. And then the games, well, 75% of 8 is 6. So 6 games are science fiction. How many games are not science fiction? If he's got 8 in total, well, that's going to be 2. So then the number of combinations that are non-sci-fi is going to be 10 times 5 times 2, which gives me an answer of 100. Then moving on to question 5, it says that Flynn has a toy in which you can pick a face, body and a pair of legs. It comes with 8 faces, 6 bodies and 5 pairs of legs. How many different combinations does the toy have? Well, this one is just going to be 8 times 6 times 5, which gives me an answer of 240. It then says Piper has the same toy with the same number of faces, bodies and pairs of legs. They both customise their toys at random. What is the probability that both Flynn and Piper customise their toys with the exact same way? Now, for this particular question, it's really important that you see the situation for what it is and then try and work that one out. So here we've got no idea how many faces, how many bodies, how many pairs of legs Piper has. So we don't know the probability of her selecting one. So rather than looking at what's the probability of Piper picking the same one as Flynn, we'll look at this question as what's the probability that Flynn picks one that is the same as Piper. Now, if you think about that, then the probability that Flynn has the same one as Piper is going to be one of the combinations that he's got to choose from. So for this one, it's just simply going to be 1 out of a total of 240 possible combinations. So try and look at this question as what's the probability that Flynn has the same outfit as Piper on his toy, or on their toy, I should say. Moving on to question 6, it says that a shop sells 8 types of butter, for which 3 are dairy free, 12 types of cheese, which are 2 are dairy free, and Nusha can only eat dairy free products. What percentage of butter and cheese combinations can Anusha buy from the shop? So for this particular question, let's have a look. So for this, the possible dairy-free combos is going to be, well, it's going to be 3 times 2, which is 6. Now the total number of possible combos is going to be 8 times 12, which is, let me just quickly work that out, which is 96. So then it's going to be 6 divided by 96 multiplied by 100, in which I get an answer of 6.25%. Then moving on to question 7, it says that Dodie makes a 6-digit number using all of these cards. How many different numbers greater than 700,000 can they make? So let's have a look. So in order for it to be greater than 700,000, so for it to be greater than 700,000, it needs to start with either 8 or 9. So starting with 8. So if we know that the first number is going to be 8, so that can only be one number. Then if one number is taken, we've got 1, 2, 3, 4, 5 to choose from. So then it's going to be 5 to choose from. Then 1's taken, so that's then going to be 4. Then it's going to be 3. Then it's going to be 2. And then it's going to be 1. So then if I multiply all those numbers, I get 120. So then if I then think that the number starts with 9, then again the first number can only be 9, so that's only one option. Then the second number, well, I've got again 5 numbers to choose from. Then if I've taken 2, then I've only got 4 to choose from. I've taken 3, I've only got 3 to choose from. Taken 2, I've got 2 to choose from. Taken 4, I've got 2 to choose from. And taken 5, I've got 1 to choose from. And again, that comes up with 120. So the total number of combos is going to be 120 plus 120, which is 240. Then moving on to our last question, it says Craig has a briefcase with a 3-digit number lock on it. They want the first digit to be an odd number and the last digit to be a number less than 6. How many possible combinations are there for Craig to choose from? So in terms of the first digit to be an odd number, well, odd numbers are either going to be 1, 3, 5, 7, and 9. Then for the last digit, so that's the first digit, the last digit, the possible numbers that we could have are going to be 0, 1, 2, 3, 4, and 5. So looking at this, for the first digit, it can be a possible of 5 numbers. The second digit has got a possibility of having 10 digits. And the third digit has a possibility of 6 options. So if I then multiply those 3 numbers together, I get my correct answer of 300, and that is the end of this topic test on probability and combinations.